Oh no, Mike. I think you're ready now to the damn video starts. All right, here we go. All right, so I am starting section 4.3 next week because section 4.3, we skip 4.2, we go right to section 3. Section 4.3 is how to solve a quadratic equation. We just graphed them. Now you're going to have to solve a degree 2 equation for x. These are more complicated equations, so there's more than one way to solve a quadratic equation. However, the first way you are always taught to solve a quadratic equation is by a method called factoring. Now, you are supposed to know what factoring is, but I don't know how Algebra 1 ended for you guys because of COVID, so I'm starting from square one. So before I ask you to solve a quadratic equation by factoring, I want to take this week and make sure you know how to factor. So when you have to solve by that method, you know how to factor. So I always like to start with numbers before we have to factor algebraic expressions, because that always becomes harder to look at and harder to learn. So when I ask you, what are factors of 8? Can somebody tell me what factors of 8 are? Go ahead.
1 and 8.
1 and 8, I love those first. 1 and 8. And then what else are factors of 8? 2 and 4. And the reason these are his factors is because factors are numbers that multiply to 8. They are numbers that live inside of 8 to create 8. They have to multiply to equal 8. So when you are asked to factor something, you are breaking it up into pieces that multiply. That is exactly what factoring means. You are breaking it up into pieces that multiply. I am going to be the most annoying person this week because I'm going to ask you every day, guys, what does factoring mean? It means to break it up into pieces that multiply. Because I need you guys to see the word factor and say, I got you, Hardy, I know exactly what I have to do. I have to break it up into pieces that multiply. When I, in a month from now, say, hey guys, can you factor that real quick? I need you, like, oh, that's fine, Hardy. I'll break it up into pieces that multiply. That's what factoring is, okay? Not only do factors multiply to 8, what do all of these numbers also do to 8?
When they multiply.
They multiply to equal. They also divide evenly in. They live inside of 8. Excellent, Jake. All right? So factors multiply to equal 8. They will also divide evenly into 8. They literally live inside of 8. All right. So if I ask you, what are factors of 15? What numbers multiply to make 15? 1 and 15. And then what else? 3 and 5. Beautiful. Those are factors of 15. We have broken 15 up into pieces that multiply to equal it. That's what factoring means. So guys, when you factor a number, his factors are numbers, 3 and 5, 1 and 15. You are going to be asked to factor mathematical expressions. So when you factor a mathematical expression, you have to break it up into littler mathematical expressions that multiply to equal it. So it's always going to be more complicated when we start throwing in the variables and the expressions. So take advantage and literally know what this means when we're just doing it with numbers. If I asked you what are factors of 24, what are factors of 24? 1 and 24, or I like to go in order. I love that. Anything? What are other factors of 24? 2 and 12. What else? 3 and 8. 4 and 6. Beautiful. These are all numbers that multiply to 24. So we have factored 24 by breaking it up into pieces that multiply to equal 24. That is exactly what we're going to have to do. You're going to have to factor quadratic equations. We're going to have to break it up into tinier expressions that multiply to equal that quadratic. All right, so I want everybody to write this down. What does factoring mean? It means to break it up into pieces that multiply. You need to see that F word and know exactly what it means. We are breaking it up into pieces that multiply. Okay, So I'm going to go all the way back to the basics today. I'm going to start from square one because like I said, I don't know how much you guys remember of this from Algebra 1. And when I tell you, factoring is a skill that you have to learn in Algebra 2. It will never go away for the rest of this school year. It is something we will use all the time now. If you take pre-calc next year, they use it on a daily basis, every section, every single chapter. If you take a college entrance math exam, factoring will be on it. The GPA test that you're going to take in 3 weeks, I've already seen factoring on the practice test. I am not lying when I tell you this is a skill you have to have when you leave Algebra 2. All right? All right, so let me give you your notes. Let's do the damn thing. But like I said, I am starting at square one. I am taking this all the way back, thank you, to the basics. So don't be absent this week. You can't afford to miss this week.
So be absent the entire week. Just kidding.
All right, so guys, on the top of your notes, what does factoring mean? It means to break it up into pieces that multiply. I'm probably going to make you say that every single day, multiple times a day. I need you guys seeing this word and knowing exactly what you have to do.
Did we have homework on Friday?
Yeah, but you probably finished it in class if you remember. It was just a quick FOIL review, and mostly everybody finished it in class. All right, here we go. Factoring means break it up into pieces that multiply. So we have to break up these mathematical expressions into other expressions that multiply to equal them. Okay. First, I just want to practice finding greatest common factors. Because I feel like a lot of times people confuse greatest common factors with least common multiples. Multiples are numbers that another number can become. They get bigger. Factors are numbers that create this number. They're smaller than it. They live inside of this number. All right, so the first way you are taught to factor ever is by factoring out your greatest common factors. That's the kind of factoring we're going to do today. So what is the greatest common factor, otherwise known as your GCF? The GCF is the biggest number and or variable that is common to all, that is common to everything in the expression. All right? Another way to think of it is the biggest number that divides evenly into all of the other numbers in the problem, okay? Now, the GCF, guys, it can be just a number. It can be just a variable. It can be a number and a variable, okay? So keep that in mind. And then when it looks like they don't have a GCF, but they have nothing in common, what is the one number that is common to every single number in this world? One. All right, so everything has a greatest common factor of 1. However, it does not help us because 1 doesn't change anything. 1 times 5 is 5. It's still 5. Taking a 1 out doesn't change 5, okay? All right, here we go. So let's practice finding a greatest common factor first before you're asked to factor using it. So guys, if I give you the two numbers 8 and 26, and I asked you, what is their greatest common factor? I literally say to myself, what is the biggest number that divides evenly into both 8 and 26? It is 2. 4 does not divide into 26. Now let me show you my trick. This is how I do it every single time. Guys, look at the two numbers you've been given, 8 and 26. What is every single number's biggest factor? Itself. Every single number's biggest factor is itself. So when you look at these two numbers, who is 8's biggest factor? So that's the biggest number that his greatest common factor could be, because that's his biggest factor. He doesn't have any factors that are bigger than himself. They don't make 8. So when I'm looking at 8 and 26, the biggest factor they could have in common is 8. So I always try the little number first. Does 8 divide into 26? So he's not a factor of 26. So 8 is not your greatest common factor. So that means it's something smaller than 8. because it couldn't possibly be something bigger than 8, or else it wouldn't be a factor of 8. So you always start at the littlest number, and you work your way down. So if 8's not it, think of another number that divides evenly into both 8 and 26. And who's the biggest one? It's 2. So guys, even though it's the greatest common factor, it might be a little number. It might be 2. That might be the greatest number that they share as a factor that divides evenly into both. So in this case, it's 2. All right. What if I asked you, and please listen to my question, because I'm trying to get you guys in like a rhythm here. If I asked you what the greatest common factor of 12, 28, and 8 is, who's the biggest number that could be an answer to that? 8. That's his biggest factor. So it's either the littlest number or something even smaller. So always try 8 first. Does 8 divide into 28 and 12? Then it ain't 8. So now we're working our way down from 8. Find me the next biggest number that divides evenly into all 3 of these numbers. It's 4. 4 is your greatest common factor. Now here's how you can test it. If you're like, I don't know, Hardy, did I get the biggest one? Well, then do this. Divide your numbers by, guys, which 12 divided by 4? 3, 28 divided by 4, 8 divided by 4. Look at the numbers that are left over. As long as they don't have a common factor other than 1, you know you picked the biggest one. If you didn't pick the biggest one, then they would have a common factor living inside of all of them still. So do 3, 7, and 2 have a greatest common factor other than 1? Then you know 4 was your guy. 4 was their greatest common factor. He didn't leave any leftover factors. Let's do the next one. If I asked you, don't say it out loud, to find the greatest common factor of 24, 3, and 9, just tell me who the biggest number it could possibly be is. 3, because that's his biggest factor. Nothing bigger than 3 is a factor of 3. So if it's going to be any number, it's either 3 or something even smaller. So guys, does 3 divide evenly into the other 2 numbers? Yeah. Then who's your GCF? 3. Beautiful. Beautiful. All right. What about 2, 11, and 15? Who's the biggest number it could be? 2, because that's his biggest factor. Does 2 divide evenly into 11 and 15? Nope. So then who's the only number smaller than 2? 1. So 1. So here's where you'll argue that they don't have a GCF because 1 really is not going to help us in the grand scheme of factoring. However, everything does have a common factor of 1. So we're going to say 1, but I guarantee you somewhere during this week I'm going to say it's none, they don't have 1 because I don't really count 1. It doesn't help us. All right? All right, now we got to do variables. The variables are meant to be very, very easy, but students always want to overcomplicate that. So now think of this. If I asked you to find the greatest common factor between x squared and x to the 5th, guys, break it down just for this one. How many x's live inside of x squared? 2, that's x times x, right? How many x's live inside of x to the 5th? 5, that's x times itself 5 times, right? So now if I asked you, what is the most x's they have in common? How many x's could you match? What's the answer to that? 2. The most he has is 2. So it could only be the littlest variable. So when it comes to the variables, it's always the littlest one. Because an x squared will not have any more than 2 x's to have in common with any other x's to any power. So it's always the littlest variable. Go ahead, Danny.
It doesn't matter. 2 doesn't go into 5.
Nope, it's not like we're dividing this time. These are exponents, they're not numbers. All right, so it's all, you're trying to think about how many x's they have in common. So again, it's always the littlest variable, or smallest, sorry. I know, I should probably say smallest. Variable. All right, no matter how many times I say that, students are still saying the wrong answer. It is the smallest variable there. All right, here we go. So now if I asked you, and let's do this in stages. If I asked you what's the greatest common factor of a 2x to the 6th and a 10x to the 3rd. Guys, do the numbers first. What's the greatest common factor of a 2 and a 10? 2, beautiful. And now what's the greatest common factor of an x to the 6th and an x to the 3rd? What's the most x's they could have in common? 3, the smallest one. So it's x to the 3rd. It's 2x to the 3rd. The variable should just be the littlest one there. All right, look at the next one. What if I asked you, What's the greatest common factor of an 8x squared and a 16x? Do your numbers first. Who's the greatest common factor of 8 and 16? 8, right? Because that's the biggest number it could be, and he does divide evenly into the other number, so it's 8. And now, how many x's do they have in common if he's an x squared and he's, a just x? 1x. The GCF is 8x. It's always the littlest variable. All right, and the last one. What is the GCF between a 6x and a 15? What number would we land on?
1.
Who's the biggest number it could be?
6.
6 don't work. 6 don't divide into 15. It's not a factor of 15. What's a number smaller than 6?
3.
3 is your GCF. All right, and then if he has 1x and he has no x's, how many do they have in common? No, so it's just a number. You can't force it. Everything has to have x's in order for them to have an x that is a part of their GCF. It has to be common to all. All right, how do we feel? Do we feel okay?
Yeah.
All right, so what we're going to do is we're going to factor. And what does factoring mean?
To break.
Break it up.
Yeah.
I'm going to be so annoying about that. So we're going to break expressions up into pieces that multiply using their GCF. That's going to be the first piece that we break the expression up into. This GCF times what else gets us the original expression. This is usually the first form of factoring that you guys are introduced to, is factoring by GCF. So this is where I want to start, because it's always the first step of factoring. All right, let's do it. So I tried to make it organized for you guys, so I put this little GCF line. We're going to find the GCF, we're going to write them there, but that's not our answer. We have to factor these expressions. We have to break them up into pieces that multiply. All right, I think I changed the directions on yours, so I think your directions say factor each expression using the GCF, because I want you guys to get used to seeing the directions factor. So when you say factor, like, oh, okay, Martha, I'm going to break it up into pieces that multiply. All right, here we go. So guys, our job is to take this mathematical expression and break him up into two pieces that multiply to equal this. So the first piece we're going to break him up into is his GCF. So guys, when you go to find a GCF, don't worry about the sign. The only time we ever take a sign with our GCF is if it starts with a negative number. If it starts with a negative, then we're going to pull a negative out with our GCF. But if it starts with a positive number, then our GCF is positive. Is everybody okay with that? Yeah. All right, so GCF. Let's do our number first. What's the greatest common factor of a 4 and a 10? 2. And then let's do our x's. What is the GCF of an x squared and an x? 1x. So your GCF is 2x. So that is the first piece we're going to break this expression up into. So we're going to say 2x times what other expression equals this expression. Now this is how I do it. And then I'm going to show you what the book is going to tell you. But I like my way better. So we're trying to break this up into two pieces that multiply to equal this expression. So guys, think of distributive property. If you were going to distribute 2x back in, this times what gets you back to the original. So 2x times what gets you back to a 4x squared. 2x. Beautiful. All right. And then 2x times what could be next would get you back to a negative 10x. Negative 5. Close catapult. And you have just factored that expression into two pieces that multiply to equal it. You've broken it up into this and this. And you can always check it. Guys, distribute it back in. Is 2x times 2x going to get you 4x squared? Yeah. Is 2x times negative 5 going to get you negative 10x? Totally. You have just factored that expression. Go ahead, Dad. No, so I just did this to organize you guys, to find your GCF, and then you're going to use it to break it up. This is your answer, though, Darian. This.
Oh, yes.
Okay? So this is not going to be part of your answer on your homework tonight. This is what you need to do. Okay? All right, now, this is what the book would tell you to do. And this always helps some students, so I definitely want to show you this. My way of thinking is always, let's break it up into two pieces that multiply. So I take my GCF, and then I ask myself, what do I need to get back? Technically, the book would say, once you find your GCF, you're going to use him as your first factor. But then all you need to do to get this is just take everything here and divide your GCF out. So now, to get this, guys, what's 4x squared divided by 2x? 2, see, you have to know exponent rules. 4 divided by 2 is 2. What's x squared divided by x? 1x. And then what is a negative 10x divided by a positive 2x? A negative 5. I don't like to do that. I just ask myself, this times what gets me back? But that's another way to find out the second factor. Just divide your GCF out. All right, here we go. Let's do this one. If I asked you to factor this expression, I need you to break it up into pieces that multiply. So the first piece I want you to break it up into is this GCF. So guys, what is the GCF between these 3 pieces? 3, okay? Again, that's just for organizing. So we're going to take 3, and we're going to times it with what to get back to this expression? 3 times what gets you a 3x squared? 1x squared. That didn't sound good. Are we okay?
No.
Yeah.
3 times what gets you back to a 3x squared? A 3 times an x squared gets you a 3x squared, right? Okay, notice, guys, our GCF was just a number. We didn't take a variable out. So nothing should change your variables. You didn't take any of them out. All right, 3 times what gets you back to negative 30x? Negative 10x. And then 3 times what gets you back to positive 18? 6. Close catapult. You're done. You have just factored that using his GCF and another expression that will multiply to equal the original. And you should always check. Make sure if you distributed the 3 back in, he gets you the original. They're supposed to be factors of it. They should multiply to equal that. If they don't, then you didn't factor it right. Let's keep going. We got to get on a roll here. All right, look at the next one. What is the greatest common factor of these 3 terms?
2.
2. It's just 2, right? They don't all have a variable, so they couldn't possibly have a variable in common. And the greatest common factor of 2, 6, and 80 is 2. So guys, don't be alarmed if you're like, Hardy, it's the greatest common factor, but it's just this little 2. Just because it's the greatest common factor, it has to be this huge number. You got that? All right, hold on, we read. All right, so guys, take your 2. That's our first factor. Then we're going to times it with what to get back? 2 times 2 gets you 2x squared. X squared. 2 times 2 gets you 6x. 3x. 2 times what gets you negative 80? Negative 40. Boom. Close catapult. Done.
Close what?
You know Sandlot? Close catapult.
Well, yeah.
It always makes me, when I close a parenthesis, I always feel like close catapult. But you have to know Sandlot. You have to know small.
I've never watched
Killing me, small.
You've never seen Sandlot? Dang. Friend.
Killing me,
You
small.
guys. You don't understand. That movie is so good.
Wait, isn't that the one where it's
You're
like,
killing me, Smalls. How can I have some more
Yeah.
if I never had some at all? Oh my God, homework. Watch Sandlot. It's a cult classic. All right, here we go. Now we're going to start bringing variables in. So now we have to get used to this. But remember, if you find the GCF of variables, it's always the what? The smallest one. Don't make it any harder than that. All right, here we go. Let's do our number first. What is the greatest common factor of 15, 9, and 6?
3.
3. What is the greatest common factor of x to the 4th, x to the 3rd, and x squared?
5x
X.
to the 2. Or to the 5.
X squared. All right, it's always the littlest one there. And then if they don't all have a variable, you can't use it as part of your GCF. All right, so now here we go. This gets a little bit more confusing for students because he has 4 x's, he has 3, and he has 2. At most, how many could they have in common? 2, because x squared only has 2. So that's the only amount he could have in common with the others. If they all have a variable, then there should be a variable you can take out. Like up here, they didn't all have a variable, so you couldn't take a variable out. But if every single term has an x, then there's a certain amount of x's that they have in common. Okay, here we go. So the first factor is going to be 3x squared. Now we're going to multiply it with what other factor to get back here? Now just
5x.
Okay, yes. All right, so 3 times 5 gets you 15, and then this is how I do it. However many x's you take out, subtract them away. If I took 2 out, how many of his are left? 2. So x squared. They should add back up to what was there. Because if you guys remember your exponent rules, when you are multiplying, you add your exponents. That's something we're going to review in chapter 5, unfortunately. All right, now here we go. Let's do our number first. Just take it in steps for me. 3 times what gets you back to -9? -3. And then if I took 2 x's out, how many of his are left? 1. So he should be a -3x. 2 and 1 add back up to 3. Your exponent should add back up to what was there. All right, now here's the part where you gotta wrap your head around this. 3 times what gets you -6? -2. Now, if you took 2 x's out, how many of his are left? None. So he doesn't get an x. You don't need a variable there to get back to what it was. Because watch, you should always check. Does 3x squared times 5x squared get you 15x to the 4th? Yeah. Does 3x squared times -3x get you back to a -9x to the 3rd? Yeah. If you tried to put an x here, because students always want to say, oh, there's got to be at least an x left, right? 3 times -2 is -6. X squared times an x will get you back to an x to the what? A 3rd. That's why he can't be there. You only need a -2 for this times this to get you back to -6x squared. Is that okay? Because I feel like students always want to throw an extra variable in there. And I'm just telling you that some of these aren't going to have a variable left because he was probably one of their x's and he's gone now. All right, let's do it again. Let's see. What is the greatest common factor of an x to the 3rd, a 4x squared, and a -x? First of all, who's the number? 1, because it's got a 1 in front and then a -1x in the back. So the biggest number it could be is 1, and that's normally what I would say 1 ain't going to change anything. Because, guys, if I throw a 1 in front, 1 times what is this? Nothing changes when you pull a 1 out. All right, but they all have variables. What is the biggest number of x's they have in common? Just 1, the little 1. So the GCF is just x. That's the only thing we're going to factor out. So if you only factor out a variable, none of the numbers in front should change because you didn't pull any numbers out. All right, so here we go. So let's say we take 1x out. So 1x times what gets you back? So guys, if you took 1x out, how many of his are left? X squared. You don't need a number because I don't want to put a 2 in front. That would get me back to a 2. It didn't have a 2. So 1x times 1x squared gets me back to 1x to the 3rd. Just subtract his exponent out. All right, x times what gets you back to a 4x squared? A 4x.
I put 0.
Oh, no, you can't.
Can't do that.
No, and I'll explain why. So now here's where students get tripped up. They're like, okay, x times x squared gets me x to the 3rd. X times 4x gets me 4x squared. X times I took him out, I'm done, close it. Here's why you can't close it. You have to make sure that, guys, these are factors of this expression. They have to multiply back together to this. So if you ended it here, x times x squared gets you x to the 3rd. X times 4x gets you 4x squared. X times what gets you back to that? You have to have something there. So now x times what gets you -x? -1. Yes. You have to put -1. You can't put 0 because x times 0 would be 0. We're not trying to get back. And I'm not picking on you there, but that's what you have to make sure. You have to make sure it gets back to the original. Does that make sense? Is everybody okay with that? Yes? All right, couple more.
This is actually really kind of easy.
It should be. It really, this is as basic as it's ever going to get. The variables do tend to mess people up, but we got to get used to that because they're all going to have variables soon.
Wouldn't the next one be 4 is the greatest
All right, wait for me. You'll ruin it. All right, the next problem. Sorry, my word's getting very dirty. What is the greatest common factor of 12, 8, and 20?
4.
4. It is 4. It could have been 8, but then 8 doesn't divide into the others, so we work our way down. Now, when we look at the variables, what is the greatest number of x's they have in common? 3. They all have x's. The littlest one is the most they could all have. All right, so let's break this up into 4x to the 3rd times what gets me back to this? All right, 4 times what gets you 12? 3. If you took 3 x's out, how many of his are left? 0. So he doesn't get an x. It's just this times 3 gets you 12x to the 3rd. Is everybody okay with that?
Yeah.
All right, 4 times what gets you -8?
2.
Ooh, -2. And if you took 3 x's out, how many of those 5 are left? 2. All right, now we go. 4 times what is -20? -5. If I took 3 x's out, how many of his are left? X to the 5th. Close category. Done.
Okay, sorry.
All right, next. Now listen, this is like a quintessential GCF problem for Algebra 2. Listen to me. Are we gonna have to solve quadratic equations that look like last one? Oh no, that's not even a quadratic equation. But I just want you guys getting comfortable with the GCF. So we can find it. Are we gonna have to solve one like that? Guys, don't freak out. No, we are not.
So.
All right, here we go. We're gonna do our numbers first, then we're gonna do our x's, and then we're gonna do our y's. So what's the GCF of a 25, 15, and 5? 5. All right, let's do our x's. What's the GCF of an x to the fourth, an x, and an x to the third? Somebody said it. An x, one x. And then let's do our y's. Y squared, y to the sixth, and y to the fourth. Who's there? Y squared. Yeah. So now it's the same thing. We're just gonna have one other variable to subtract out of the problem. All right, so that's our GCF. So we're gonna factor this and do his GCF times what other factor will get us back. So one thing at a time, guys. Take your time. 5 times what gets you back to 25? 5. If I take one x out, how many of his are left? X to the third. If I take y squared out, how many of his are left? Nothing, they're gone. So this does not need any y's, because when I multiply this y squared back in, y squared times none, get me y squared. He doesn't get a y. You took all of his out. All right, let's go to the next term. 5 times what gets you negative 15? Negative 3. If I take an x out, how many of his are left? 0. They're gone. He does not get an x. You've already taken him out. When you multiply this one back in, it'll replace him. All right, if I take 2 y's out, how many are left there? 3. No. Oh. 4. Right, you had 6, you took 2 of them out.
Oh, yeah.
All right, and then last. 5 times what gets you to positive 5?
X.
Mm-mm. Well, just stay with me. Answer my question. 5 times what gets you to 5? 1. So a plus 1. You might not need the plus 1 once you start adding the x's, but let's put them there for now. If I take an x out, how many of his x's are left?
2.
X squared. Beautiful. Now again, I probably don't need that 1 in front because it's assumed to be an x squared, but I would just leave it at this point. If I take 2 y's out, how many of his are left? 2. Close it. You're done. So guys, they can keep adding variables. It's all about just subtracting the exponents out. Go ahead. Yeah, absolutely. All right, you can figure it out. All right, so guys, for homework, your homework is on Delta Math. If it seems really easy, it's because to get an assignment on GCF, I had to pull from Algebra 1. So they're pretty basic expressions. These are much harder. So I just want you practicing finding a GCF, but the homework should feel a lot easier. The first 5 questions just ask you, what is the GCF? And then the next 10 is factor using the GCF, okay? But it's quick. This goes super quick. Wait till you see how small it is. All right? So that is due tomorrow night at 11:45.
Hey.